And introduce you. So today, ending our seminar series for the fall semester, we have Alyssa Hasagawa-Smith, who's a PhD candidate at the Network Science Institute at Northeastern University in Boston. Alyssa is sponsored by an NSF GRFP fellowship in social sciences, and her work focuses on the human impacts of and the way that humans can impact socio-technical systems. So this implies a lot of different kinds of networked phenomena that Alyssa will tell us about today, and that I'm very excited to hear about. So with that, I'll go ahead and mute myself and please take it away, Alyssa.
Wonderful. Thank you so much for that lovely introduction. And thank you everyone for being here. I'm really excited today to talk about what shapes network structure on social media platforms. So without further ado, let's dive in. First of all, why am I giving this talk? I don't have all the answers as to what shapes network structure on social media platforms. If I did, I don't think I would be a PhD student anymore, and also that would be kind of boring. So I'm giving this talk because I want to build new research collaborations. I want to see who's asking similar questions to what I'm looking at from different angles. And I also want to tell people about a cool new data set that I've been working on. So that's why I'm here today, and I'm really excited to hear your thoughts on this talk. So why do we care about networks on social media? We care about networks because networks are kind of part of what drives our attention on social media. So what are we looking at? What do we care about? Curation, what kinds of information do we see? Um, how are algorithms delivering particular kinds of content to us that seem like they would appeal to us? And how does information diffuse through networks? So networks have implications for things like trending topics and new memes, like Mudang, the baby hippo. Mudang is a networked phenomenon, even if she is just one hippo. Um, Mudang did not become famous because a bunch of people in a shadowy room were like, you know what the internet needs? A hippo. She became viral organically through a networked process of virality. So there are baby hippos. Those are cute. Those are very exciting. But we also care about networks because when things spread on the internet and when people see things that become visible from people who are super central in the network, we can see phenomena like polarization, radicalization, and offline harm. So, for example, Libs of TikTok, which is a popular Twitter/X account, um, often will spotlight particular liberal gyms or schools or hospitals that they think are doing quote unquote liberal stuff. Um, and then bomb threats will follow these posts. So um, the network spread of ideas, of information, has implications offline. What I'm interested in looking into today is how endorsement and platform affordances, so the things that you can do on a platform that the user interface allows for, inform network structure on the platforms. So how do these networks through which we get polarization, we get Mudang the baby hippo, we get offline harms, how are these influenced by structures of endorsement? So maybe retweets, maybe blue sky starter packs, which I'll talk about later on, as well as the things that you are able to do on a platform. So the features that you're able to interact with inform the structure of the networks that we end up with. So I'm going to go through two pieces of work. One of these is already published, and another is still in progress and involves a really exciting data set. The first one, which is already published, is called Emergent Structures of Attention on Social Media Are Driven by Amplification and Triad Transitivity. You may be wondering why there's a cat there, and I promise we'll get to that in a second. This is joint work with John Green, Brooke Foucault-Wells, and David Lazar, and it was published earlier this year in PNAS Nexus, if you want to take a look. Um, so I'm going to just start by diving into some brief background that you may have already seen if you're interested in social networks. First of all, we want to think about bridges and brokers. So in this little network, toy network diagram, we have two sort of communities, the green community and the light blue community. And then we have some nodes that are connecting multiple communities. We know from Granovetter and the strength of weak ties that folks who have ties to multiple communities that are generally weaker ties than the ties that bind them inside a community tend to have access to novel information and potentially unique insights. We also know from Burt's structural hole theory that people who bridge gaps between communities have access to this novel information, um, and tend to be able to game the fact that they bridge a structural hole between communities and therefore gain advantage in a network and gain social capital. Um, these bridging nodes also have the ability to connect people across communities. So another idea that's important to this work is the tertius jungens, which is Latin for third who joins. This is someone who helps create links as a mutual acquaintance or friend or tie. So if I am the red node right here, and I know both Alice and Bob, but Alice and Bob don't know each other, and I go then and I introduce Alice and Bob, I'm actually acting as a third who joins. I'm bringing Alice and Bob together, and in doing so, I'm providing a novel avenue for information to be exchanged, and I'm creating a new link between two different communities. So we know from Obstfeld's work that the tertius jungens or third who joins, um, when there are more of those in a corporation, the corporation tends to be more innovative. And in a second, I'll talk about how this idea of a third party creating new ties can generalize to social media and amplification phenomena. The big ideas that I would like you to walk away from this talk with, or this part of the talk at least, is that attention brokers, which are a kind of user that we talk about in this paper, are influential users who frequently amplify content. They create new ties in their network by exposing their followers to novel content, specifically through amplification. And in doing so, these attention brokers shape attention patterns on Twitter/X and probably on other platforms and in other settings as well. So, attention brokers, another way we can think of them is the third who amplifies. By amplifying novel content, they make it more likely that new ties form and therefore shape attention in their immediate networked neighborhood. And we hypothesize also more globally within the network. Now, let's harken back to the random cat that I showed you before, and we're going to go through an illustrated example. So here is some entertaining backstory for you. This is Jorts the cat. Jorts the cat was the subject of a viral Am I the Asshole post, I think in the early 2020s, maybe like early 2020, where a human posted about an orange cat named Jorts who is kind of struggling with being a cat. He lives in an office, he's one of two cats, and he's kind of a hapless cat. One of his coworkers was trying to help Jorts the cat be a less hapless cat, and there was a debate between the Reddit poster and this other coworker about whether Jorts should be left to be hapless and embrace his hapless nature, or whether Jorts needed to be helped to be a better cat. This post went incredibly viral on many social media platforms, and shortly after this post went viral, the human who originally posted about Jorts the cat made a Twitter account in the persona of Jorts the cat. Importantly, this cat Twitter account became famous for being a funny cat on the internet. However, in maybe a few days after the account was created, this person in the persona of Jorts the cat started posting about labor activism and unions and unionization and really supporting like multiple unions, supporting strikes, supporting, I think, Starbucks workers at the time, um, and amplifying a lot of content related to labor activism. So even though Jorts became famous for being a cat and gained a lot of initial followers for being a funny cat, he also exposed these followers to labor activism, and Jorts is one of the two case studies we look at in this paper. So what does attention brokerage look like with Jorts the cat? First of all, we have a labor activist tweeting about their work. You know, maybe they're posting a meme, they're posting about a strike, what have you. Jorts is following this labor activist because remember, he's very plugged into unions and labor activism. So he sees that tweet and he retweets it. He amplifies it for his followers to see. Someone sees that retweet, one of Jorts's followers perhaps, and thinks it's great, you know, absolute banger tweet, really interested in labor activism, even though they maybe hadn't considered it before. So they decide to follow the labor activist. And importantly, the user interface on Twitter makes this very easy because amplification happens with attribution on Twitter. So when I amplify a post, there's a very easy link to click on the profile of the person whose post it originally was, and then another button to follow them. So 2 clicks, and you can follow the original poster of something that was amplified. So this is an example of Jorts acting as an attention broker, bringing together two potentially disparate parts of Twitter, labor activists and people who are interested in silly cats. And it's also an example of triad transitivity. So this is the directed equivalent of a closed triad where all three people know each other. So this one's a transitive triad, um, where Jorts is following the labor activist. Jorts's follower is following Jorts, and then the triad becomes transitive once the Jorts follower follows that labor activist. So that's where the triad transitivity in the title of the paper comes in. We're seeing a lot of open triads turning into closed ones because of Jorts. But this is basically a theory at this point, and science is not built on vibes. So what we kind of ask in this paper is, what if this person did not follow Jorts? Would they have actually gone and followed the labor activist? And in order to figure out whether this is the case, whether attention brokerage is empirically happening, we have to get a lot of data and do some causal inference. So that's what I'm going to dive into next. First of all, this is all of what we measure in this project. First of all, we estimate the population of the active followers of jorts, so people who are followers of jorts and who semi-regularly are paying attention and following other accounts. We also estimate the population of everyone on Twitter who is active in this general area of Twitter, following other accounts, and generally paying attention. And if you're interested in the nitty-gritty of how we did that, I'm happy to talk about it in the Q&A. Next, for every account that Jorts retweets, we label it as whether it is labor related, so that's a binary label, um, and we collect time-bounded following events within plus or minus 2 weeks of the retweet. So we have a 4 week span of following events, and we know for sure which ones occurred in the 2 weeks before the retweet and the 2 weeks after the retweet. And depending on how many follows occurred, we might have coarser or more precise time bounds on when these following events occurred. And I can also talk about that trick in the Q&A if you're interested. We then interpolate the number of follows that happened per day in this 4 week period. And from there, with our population estimates, we calculate the daily per capita follow rate for both active followers and active non-followers, because we know of the accounts that followed the retweeted accounts, which ones were following jorts at the time, and which ones definitely were not. So here's a visual depiction of what we're measuring. So for every account A, so this labor activist, perhaps this guy in a hard hat, retweeted by Jorts, we're going to compute the number of follows to this account by followers of Jorts over the total population of active followers that we estimated. For the follows to, we're also going to compute the equivalent quantity for people who are not following Jorts. So these non-followers, this active non-follower population. In other words, what we're computing is the rate at which triad transitivity happens and the rate at which we build equivalent open triads. So that is what we're measuring. And importantly, account A is one account of around 700 accounts that we looked at. And what we're going to do next, looking at these two trajectories for the followers in red and the non-followers in blue, is we're going to aggregate this data and figure out what effect Jorts has on average over many accounts. So what are we looking at here? This is the average number of follows to retweeted accounts per user per day with a bootstrapped 95% confidence interval. Um, Importantly, you might see that the y-axis is very small. We see that this right here is about 1 times 10 to the negative 5. Jorts had around 200,000 followers at the time that we studied him. This was very early in the account's lifetime. So 1 times 10 to the negative 5 out of all of his followers equals about 2 followers following the account. Um, we see that followers have a higher following rate prior to the retweet as opposed to the non-followers. And again, this is normalized by the estimated population. We do see a spike for both kinds of accounts on the day of the retweet, but the spike has different magnitude. And we also see a little bit of a jump prior to the retweet. And what I think is going on there, but what we were not able to determine with the data that we had, is that Jorts was sometimes slow on the uptake of a viral trend and a viral tweet that was already spreading on Twitter. So maybe it was a cute cat or a funny meme. And it was going to be followed by the kind of people who are likely to follow Jorts, but Jorts was a little bit on the late end of amplifying it. So it was followed, but it was not followed necessarily at the time that Jorts retweeted it. And I can talk more about that. So we kind of called it background virality in the Q&A as well. What we're interested in figuring out using this data is how much of this change, so how much of this qualitative difference, this big spike right here on the day of the retweet, can we attribute to Jort's retweeting? And we're going to use causal inference to do this, specifically differences in differences. And we want to isolate the causal effect that being a follower of Jort's and being exposed potentially to his retweets has on the propensity that someone has to follow an account that Jorts retweets. Um, so this is a natural experiment, and we're going to use differences and differences to analyze the data we collected. So we have basically 2 groups here. We have the follower group, which we call our treatment group because they're exposed to the treatment, which is the retweet by Jorts. And then we have the non-follower group, which is the control group. These have no treatment. They were not exposed to the retweet most likely. And we track the trajectories of both of these groups before and after the treatment group is exposed to treatment. So after that retweet happens by Jorts the cat. Um, so importantly for differences in differences, we want to see that these two groups have parallel trajectories prior to intervention. So we don't want to see any trends in the followers, for example, that don't parallel that of the non-followers, because we're worried about confounders. So if something happened to the followers before the retweet, that might affect their behavior on the day of the retweet or thereafter. So we want to see those parallel trajectories, making sure that their behavior is similar before that retweet happens. And if this does end up being violated, which we suspect it was to some extent, we can analyze how robust the results were to this violation, and I can talk about that in the Q&A as well. The TLDR is that some of the effects do persist, even if there is a very large violation of the parallel trends assumption. So when we do causal inference, one of the things we need to do, or the crucial thing we need to do, is establish a counterfactual universe. So in the universe where Jorts never retweeted these accounts, what would the trajectory of the following rate of those followers be? So in a universe without those retweets, what trajectory would the following rate take? And we use the information from the control group to figure out what that trajectory looks like. So we have this counterfactual trajectory, and the comparison between the counterfactual universe and the real universe gives us our effect size. So we look at, okay, how much more people are following these retweeted accounts in a universe where George does retweet, basically. So that difference between the counterfactual and the actual is the effect size, and this counterfactual trajectory is not a real counterfactual trajectory. It's just there to illustrate what it could look like and what we could be seeing. So far we've established that we have a treatment group. So that's our people who are exposed to the retweet, who are following Jorts, as well as a control group. So those people who are on Twitter, who are active, paying attention, but not following Jorts. We see similar behavior before treatment for the treatment groups and the control groups. And we see that qualitative difference in trajectories, particularly on the day of the retweet. So we did our differences in differences analysis in order to figure out how much of this difference in trajectories we can attribute to Jorts. So let's preview what the results might look like. We can see our expected follow rate difference on the y-axis. So that's telling us what is the difference in rates in following rates between the treatment group, those followers, and the control group, those non-followers. And then the x-axis tells us the time before and after the retweet. So how many days before or after the retweet are we at, where t=0 is the time at which the retweet occurred. So one thing we could see is a negative effect, and these are also parceled out by labor-related and non-labor-related accounts. So we're going to see effect size estimates with error bars. They could be negative and statistically significant, in which case following Jorts makes you less likely to follow the accounts he retweets. It might cross the x-axis with the error bars, in which case we have no significant effect. We can't distinguish this estimate from just random noise in the data. And then we might also see a significant positive effect, in which case we know that Jorts is increasing, following Jorts is increasing the rate at which you follow the accounts he retweets. So what does this actually end up looking like in aggregate? This is what we see. So this is the full graph of the effect sizes we computed. Let's walk through it piece by piece. So before the retweet, we don't see any really strong effects. There's not much going on. We do see some very small, significant positive effects for non-labor related accounts, which I again would attribute to background virality of just random cute cat things going viral and Jort's not necessarily picking up on it until later on. And these are about 2 orders of magnitude smaller than what we see on day 0. Spoiler alert. The difference is significant on the day of the retweet, and it's pretty large. So we see this effect size being positive and significant on day 0, the day of the retweet. Um, and again, you might see 1 times 10 to the -5 and think, oh, that's pretty small. But if Jorts has around 200,000 followers and retweets around 5,000 people a year, he's redirecting the attention of around 10,000 people per year, which is the population of my hometown. And he has many more followers currently on Blue Sky than 200,000, but don't quote me on the exact figure. And then after the retweet, we see some larger fluctuations, but they're not significant. I think that if we were able to get finer timestamps, finer gradations on those timestamps of when the following events occurred, we might see more interesting effects and more precise information after the retweet as well. But we were not able to find this in this study with the data we had. So what are the broader implications of this work? First of all, we know that endorsement with attribution can lead to triad transitivity or triad closure, which can occur on social media with these following relationships. But we also hypothesize that it can happen with citation networks or perhaps even with email. These networks where people can say, oh, here's this from so, and then you can make a link with so and so who was amplified. Um, we also know that attention in terms of following ties on social media tends to be pretty sticky, pretty durable. Most following ties persist over time, so the effects of attention brokerage are lasting. These following ties generally stay put, so algorithmic recommendations might also be influenced by attention brokerage. And we hypothesize that this is a self-reinforcing process. So if I see someone retweet a cute cat, I follow the cute cat, and the cute cat retweets a bunch of other cute cats, I might be more likely to follow those retweeted cute cats. And eventually, my Twitter feed is drowning in cats, at which point Twitter probably is recommending me even more cats. And it becomes a self-reinforcing process, which is probably fine when it's a bunch of cats, less good when it's, say, a particular conspiracy theory. So I think future work could look at basically these radicalization rabbit holes that might happen through amplification with attribution. Now, I've been complaining a little bit about the data I had to work with and some of the coarseness of the timestamps that we were dealing with. So, what if we had a network data set that had a bunch of timestamps and a unique endorsement structure? That would be pretty cool. And we do, in fact, have that, which brings me to the next piece of work I'd like to talk about, which is called a Blue Start, a large-scale pairwise and higher-order social network data set. So this is joint work with Ilya Amberg, Sagar Kumar, Brooke Foucault-Wells, and Nicholas Landry. This is a data set paper that we're working with, and we are actually currently working on rebuilding and re-releasing the data set in a much better form, and that should be out probably within the next month or two, at least the data set, not the paper. Um, so let's just start with some quick background on Blue Sky. Blue Sky is a microblogging platform, so its user interface is similar to that of Twitter, and almost all of its data is publicly accessible using the API, to a degree that was not possible with the Twitter API. Rest in peace. And it has some interesting affordances. It does let you follow people with a directed tie, much like Twitter. But it also has a feature called the Starter Pack, which are user-made sets of around 8 to 150 accounts that you can follow with one click. You can also browse a starter pack. I think there's a Woman in Network Science starter pack, for example, and you can follow accounts within that starter pack more selectively as well. This gives us two network data sets. We have the following network, which is dyadic, as well as the starter pack network, which is a hypergraph. So as a visual depiction, we can have a network of following relationships where green follows blue, blue follows orange, and that gives us a little V shape. And we can also have starter packs, which are hyper edges. Each creator is automatically included in the starter pack they create. And we can see that starter pack edges can have arbitrary amounts of overlap. Um, and there are around 2.4 billion following ties in our latest version of the data set, and I think around 360,000 starter packs. So the size of the networks that we're dealing with is very different. There are also some ethical considerations involved in collecting this data set and disseminating it. Um, while this is technically publicly available data, there are possible downstream harms of having all of this information in one place and readily accessible and not anonymized. So we anonymize our data set. The users and the starter packs both have unique integer IDs, starting from 0 and going up to, I think, 39.6 million. And these are consistent across data sets. So user number 0 in the following data set is the same as user number 0 in the starter pack data set. We also truncate all of the timestamps we obtain to the day level precision. So it's not nanosecond precision anymore. So that removes another avenue for identification. And we do this for follow events, starter pack creation or addition of accounts to starter packs, as well as account creation itself. We are currently revising the data set from its earlier version. There is a version of it available at SOMAR, which is the Social Media Archive at ICPSR. And there's an older version there that does not have correct following event timestamps. When we release this data set, it will be current as, that should say early November 2025. And it will include following event timestamps, starter pack addition timestamps, so when each account was added to a particular starter pack, as well as information on each node's account status. So now I'm going to walk through some of the preliminary analyses we've done with this data, just to give you a sense of what we're working with and what you could be working with in the future. Um, so the first thing to notice is we have a data set just of nodes and node creation times. So this top plot shows us the volume of account creation per day on Blue Sky. And there are notable events that happen that coincide with often spikes in node creation, so account creation on Blue Sky. Um, we also can see node statuses. So we have around 39.7 nodes currently that are active on Blue Sky, as well as 2.2 million that were either taken down by Blue Sky. So about 1.8 million were taken down by the platform, and another 400,000 were deactivated in an action that was initiated by the user. And then we have 0. I think that says 8 million that were unknown status. So they were pointed to in the following network, but they were not, we didn't have node creation information about them. So they're kind of ghost nodes. Um, and if we just walk through some of the key events on Blue Sky, this one points, number one points to when the beta version of Blue Sky opened up. Um, Number two, really big spike in account creation when Blue Sky went public, when it was no longer based on invitation codes to get in. Um, Number three occurred when X/Twitter blocked popular accounts in Brazil. There was another spike when X formally allowed adult and graphic content on the platform. Another when Twitter was banned in Brazil. Another one when the terms of service on X started allowing blocked users to see posts and therefore really weakened the effect of blocking someone on Twitter. Sorry, X. There were new terms of service on X that allowed the platform to train AI on user content. Another spike when Donald Trump was inaugurated as the US president, and still another spike with the nationwide hands-off protests in the US. So we see these spikes in activity that correspond both to on-platform events like Blue Sky going public, as well as off-platform events, often corresponding to things that happened on X/Twitter. Now let's dive into the following network. The following network contains about 39.7 distinct users, of whom 36.7 are active. There are 2.4 billion directed following relationships, so this takes some doing to load into even a high performance computing instance, and I can talk about the requirements for that in the Q&A if you'd like. And there are 13.8 active accounts that don't have anyone following them, but only 2.4 million that aren't following anyone. Here are some plots of what's going on with the following network. We can see this is the per day following event volume. In the top plot, the bottom left-hand plot shows us the degree distributions, and the bottom right-hand plot shows us the component size distributions. So let's take a look at some of the notable features of these plots. First of all, we see an interesting exponential growth regime in following events that occurs with the invite code situation. So you had to have an invite code from someone on Blue Sky in order to join Blue Sky at that time. Um, and Everyone who was on Blue Sky only had a limited number of following codes to give out at any one time. We also see that there's a discrepancy between the in degree and out degrees area under the curve. This happens because there are more people with zero in degree, so no followers, than there are with zero out degree, so people who aren't following anyone. And once we account for people with the zero in degree and zero out degree, the average does become the same. In addition, we see that there's a really, really big giant component. So the vast majority of nodes do end up in that giant component. However, we couldn't build the network using breadth first search because, again, there were all of these nodes in other components. So if we were to use breadth first search to discover everyone in the network, we very likely would have missed a not insignificant part of the network. And finally, I want to take you through the starter pack network. There are around 2 million unique users or feeds in the starter pack, 366,000 unique starter packs. And interestingly, the user interface allows there to be between 8 and 150 accounts in a single starter pack. However, we do see some outliers because people rarely convert lists, which are another form of account aggregation, into starter packs using the Blue Sky API. So here are some plots about the starter packs. First of all, we can see this is the starter pack membership. So how many starter packs are you in? And this is the starter pack creation degree distribution. So how many starter packs did you create? And we can see that there are some people that are in very, very many starter packs. Um, we also see some outliers outside of the starter pack size that is allowed by the user interface. I think some of this is due to deletion of accounts from starter packs. Either they're deleted out from the starter pack or the account itself becomes deleted or deactivated. We also see a spike in around 50 nodes in a particular starter pack. This is because Blue Sky has a feature called Make Me a Starter Pack that will take accounts that you follow, put them in a starter pack, and the default size of that is 50 accounts. And then we do see some very small number of accounts of starter packs that are larger than 150 nodes. which is likely due to people converting very large lists into starter packs using the API. Oops, sorry, I just talked about that. So those are our sizes not allowed by the UI. So those were lists that got converted into starter packs, or maybe accounts got deleted from a particular starter pack. And then finally, we find that there is one enormous component um, in the starter pack hypered or hypergraph. This is because the Blue Sky official account is included in around half of all starter packs. So basically, you have a bunch of starter packs that are glommed together, you, mainly due to the fact that Blue Sky's official account is included in so many of them. We can also take a look at the rate at which starter packs are created over time. There was a fairly big peak in creation when the starter pack feature was launched, and then some more corresponding to the events that occurred that we talked about earlier. So X being banned in Brazil, those changes in terms of service, Donald Trump's inauguration, and then the hands-off protests in the US. We also do see some impossible starter pack creation dates, and we think that those are probably due to lists being converted into starter packs using the API or some other editing of platform data because users can edit their own data arbitrarily using the API. And then finally, this is the account age at starter pack creation. So most accounts create, or most starter packs are created when an account is very young. The most common account age for creating a starter pack is 0 days old, in fact, and there are only 8 starter packs that have impossible creation dates. So I think that one of the reasons that we're seeing these spikes in starter pack creation that correspond to spikes in account creation is because people get on Blue Sky, they follow a bunch of accounts, and then they make a starter pack all within the same day. So that's why we're seeing that correspondence in spikes, I think. Um, these are some quick links to the data sets. This is our preprint that examines our old version of the data set on the left. And then this is our old data set on SOMAR, which will be updated hopefully very soon. And if you want to beta test the new data set, please reach out to me and the team, and we'd love to talk about it. So before we wrap up, I just want to talk through some ongoing and future work that I'd like to shout out or talk about or discuss more. Um, First of all, I'm interested in the work that other people are doing to figure out if starter packs influence network structure. So Manlio De Domenico and Tommaso Bertola at the University of Padua are working on exactly this. Um, this plot is actually from the old version of our data set that did not have correct timestamps, but they did find that starter packs didn't seem to have a measurable effect on the density or maximum K-core of the network. So it's not super clear how often starter packs are being used or how much they're affecting the overall structure of the network. They also have some really cool tools on GitHub that you can take a look at, and I'm really excited to see what they learn next and what they do with this existing or with this newer version of the data set because I think they're going to find some really cool stuff um, and give us a clearer answer on whether starter packs do influence network structure. Down the road, I'm also interested in figuring out if we can distinguish follow event types because probably following someone outside of the context of a starter pack, following a subset of a starter pack, or following an entire starter pack look different in the data set. So I'm interested in figuring out, how much does each kind of this follow event occur, and do interactions between accounts differ depending on how you came to follow a particular account. And then finally, I'm interested in diving a bit more into the repost follow causality that I talked about with George the Cat. Um, I'm interested in coupling some more precise follow event timing with information about reposts from Blue Sky, studying more cases, so focusing on politicians, journalists, pundits, early adopters of Blue Sky, and highly central users in that following network. So I'm really excited to use the network that we've gathered for larger scale and more precise inference to figure out, what's going on with amplification and triad closure or link creation, perhaps. So I would love to hear your thoughts on all of this. Thank you so much for your attention. And I look forward to your questions. And let's stay in touch. My contact info is at the bottom left of this slide. So, yeah, thank you so much.
Thank you so much, Alyssa. That was a phenomenal talk. Um,
Thank you.
yeah, super, super clear, easy to understand, really interesting. So yeah, we have plenty of time for questions. People can feel free to unmute yourselves or send questions in the chat. I can read them aloud. So I'll give people a couple of seconds to collect their thoughts. And if not, I wrote down a few questions that I have.
Awesome.
Yeah, Katika, go ahead.
Hi, Alyssa. Thank you. This was a very cool talk. Um,
Thank you.
the data set that you created with Blue Sky, like that's amazing. Like, how do you deal with all that data? Like, downloading it and like storing it. Um, do you have any thoughts on that? Like, how do you manage such big data sets?
Um, that is a great question. So full transparency, I used to work as a data engineer and a data scientist, so I do have a little bit more experience
Okay.
working with this kind of stuff. I think the main thing that was most helpful for us was using asynchronous input and output when we were bringing in the data. So if I remember correctly, the bottleneck that we were dealing with when we were just pulling in data using one process at once was that it ended up being bounded by like the bandwidth and the writing to disk. When we were able to use asynchronous programming and have multiple streams of data coming in while still respecting the rate limit,
Hmm.
we were able to take in data at a much faster rate and pull in the data much more efficiently. Um, I also learned from many a large data collection gone wrong that we needed to store the data incrementally. So every time you get maybe, I don't know, a few million following events, you write those down. You don't wait for the process to finish entirely.
Mm-hmm.
Always store things incrementally. And we also use that principle when we were figuring out how to load the data set into iGraph or GraphTool,
Right.
which are the two packages we recommend for dealing with the following network.
Mm-hmm.
Um, so if you try to load the data set as a data frame and then turn that data frame into a network, having the data frame and the network object in RAM, so in memory at the same time, will eat up over 500 gigabytes of memory, and that's really not helpful. So instead, what you can do is you can read from the CSV file that we provide. And what we've been doing is pulling in maybe a few hundred million following events at a time and then shoving those into the graph object. So we're never using more than like the size of the graph object plus maybe 10% of the node or of the following events at the same time instead of having two objects in memory that are potentially the size of the entire following network. And that made that load a lot faster. When we tried to load it one by one, it was terrible. So I don't recommend loading it edge by edge either. I think that loading it in bulk is helpful. That was kind of rambly. Did I answer your question okay?
No, this is very helpful. Yeah, very insightful. I had another question. So for the Blue Sky network, I whenever I log into Blue Sky, I can feel the difference from say Twitter/X or like Facebook, like because it is there's no when the algorithm is different, right? Like
Mm-hmm,
or the post that we're looking at.
mm-hmm,
Do you think like for the Twitter X, there's like one algorithm that is defining everyone's posts and who they see, who they follow, etc. But in Blue Sky, it's so different, so personalized. And
mm-hmm,
I'm not, I could be wrong, but I feel like there's no such algorithm that is curating all the feeds. So would that, I feel like that leads to very different experiences for people and like who they follow, who they repost, etc. Like, so there's nothing universal that is guiding them. But in Twitter, you could pull out the data that you're pulling out is based on that single algorithm. So like I don't know if I'm rambling or does it make sense, but like how would you go about looking at these, the social network of Blue Sky, given all these mini personalizations and like the lack of a universal algorithm?
Yeah, I think that might be a great place for some sort of data donation setup potentially. So if we could get, maybe 1,000 people with different Blue Sky setups to give us to like fill out a survey, potentially download their data for us and send that over and we can anonymize that. I think that could be a really interesting study to run. And there's precedent for it. I know from people who had made similar setups for people to donate their TikTok data. So
Oh,
I think
okay.
that could be really fun, like a data donation scheme.
That's interesting. Okay, thank you so
Thank you
much.
so
Great
much.
work.
We have a question from Shiomara in the chat.
Uh-huh.
Shiomara says, first of all, excellent presentation. Congratulations. Then I'd like to know if in your study you were able to identify whether the topology of your complex data network is different from or similar to that of other dynamic networks.
Yeah. So when you say complex data network, are you talking about the following network or the
I'll let Shiomara clarify. I don't know. Scientific networks.
oh, okay. I'm not sure I'm like completely getting this question. But I don't think we know yet because if it's the Blue Sky data set, we've done some preliminary analyses to figure out if the data set is valid and if things are making sense. But we haven't necessarily done anything inferential or comparative right now. So we're not sure um, to what extent the Blue Sky networks are different from other networks. I think Tommaso, who I talked about his work earlier in the future and ongoing work section, has some interesting work looking at Blue Sky versus other social media networks, but I'm going to be really interested to see what he does with this new version of the data set as well. Does that answer your question? Awesome. Thank you so much.
Um, so we still have time for a couple more questions. I'm gonna chime in with one that I had.
Mhm.
So at the end of your first study, you sort of mentioned really briefly these radicalization rabbit holes.
Mhm.
And so I was wondering if from what you learned about the transitivity of the triads, if that gives you any ideas for strategies for preventing radicalization rabbit holes. Because, for example, like as much as I love cute cats on the internet, I don't want my entire feed to be cute cats on the internet, and that's like a very harmless example. So does this kind of work give you ideas for like mitigating polarization or ending up in echo chambers or these radicalization rabbit holes?
I wonder if keeping track of the clustering around someone could be interesting or useful there because if you're seeing a lot of clustering, a lot of motifs that would indicate that someone's getting redundant information or the same information, I wonder, I know there have been experiments about bringing in bridging algorithms, or so bridging algorithms being algorithms that encourage cross-cutting content that appeals to people on multiple sides of a political conflict, for example. Um, I wonder if algorithms that discourage clustering within a network over a certain threshold might be useful as well. So saying like, oh, this person is in a bunch of triangles with a lot of accounts that are also in triangles with each other. So like this looks very similar. Maybe we should suggest things that are just outside of this particular rabbit hole and try to maybe de-radicalize them in that way. So I think using clustering as kind of a jumping off point could be useful.
That's a really cool idea. Thank you.
Thank you.
Um, I still a couple more minutes. I have more questions if other folks aren't going to chime in. Um, Again with the first project that you talked about, I was wondering to what extent you could account for follower overlap. So if somebody is following both jorts and say like a labor organizer, or if they're following accounts that are following both jorts and the labor organizer, like is it is that sort of like what you were by centering the timelines on like Jorts's retweet, does that account for fo follower overlap? Because I'm not super familiar with these methods.
Um, yes and no. So what we were able to account for is whether Jort, if whether someone was already following an account. So we were able to make sure that like um following event, like we looked at crap, sorry, what am I saying? Okay, so we looked at the first retweet by Jorts of each account. So we basically looked at the first chance that the followers would have to follow that account. But in terms of having knowledge of the whole network and who everyone, every like follower that flocked to a retweeted account was following, we didn't have that information, which is something I wish we were able to obtain. But the rate limits on the Twitter API were such that we were barely able to get the data that we got, and that took months. Which is one reason that I'm really excited about the Blue Sky data set because it took us weeks to get the whole network, and that would never have been possible with the Twitter API. Does that answer your question?
Yeah, yeah. Um, I had one more question. I want to give other people an opportunity if they have questions. Um, so I'll let there be like a brief, awkward silence.
Perfect. I'll drink some tea.
Um, okay, we have another question from Shiomara.
Uh-huh.
Um, oh, it looks like this is the same question as before. I wonder if there was like a
Yeah.
typo.
Mm.
One more question. Do you plan to analyze the social media behavior, so posts on LinkedIn, X, Instagram, of researchers as part of your future work?
I think it would be hard to do on those specific platforms, unless we did another do data donation kind of study like the one I suggested before. Um, I would be interested to see, um, particularly like learning about cross-platform migration of researchers, like particularly from X onto Blue Sky. That would be one thing I'd be really excited about learning more about. And I think also looking at amplification of research on social media could be really interesting. There was a study that I talked about in a previous version of this talk, where people who were on the economics job market were randomized to be retweeted, to have their job market papers retweeted by prominent economists. And that had a significant positive effect on their job market outcomes. So I would be interested in seeing more studies like that, although I don't think I would feel comfortable running an experimental study like that. Does that answer your question? Thank
Yes.
you.
Um, I can ask one more quick one since we've got like 2 minutes. So all of my questions are apparently about the first project that you talked about. But you mentioned briefly something about having 700 accounts. Um,
Hmm.
I was wondering if there were like any kinds of like clusters in terms of like the themes that the accounts tended to be about, or were you like mostly focused on labor organization versus cats? Was that like, or was that like an illustrative example?
It was mostly labor organization versus non-labor organization. So we didn't really categorize them beyond that. Although it would be interesting to see like the mix, particularly of non-labor organizers that Jorts was amplifying.
Cool.
Cool means?
Um, With that, I think I'll go ahead and close our last talk of this semester. Um,
Yay.
Stay tuned for future talks next semester. We've got a great lineup shaping up. Thank you again, Alyssa, for the wonderful talk. And good luck with your new job. Congratulations again.
Thank you so much. Have a great rest of your day.
Thank you. You too.
Bye.